Hi, my name is Shyam Kannan. In this paper, we present our research on the design cues for external human-machine interfaces, also known as eHMIs for delivery robot. Delivery robots are getting common day by day. They share a close space amongst the pedestrians and they navigate alongside with the pedestrians. At times, there can be confusion among the pedestrians about the future navigational intent of the robot. To this end, external human-machine interfaces are commonly used so that the robot can hint the human pedestrians about their intent in advance. Displays, lights, and sounds are used by the robots to alert the pedestrian about their intent. Amongst the various interfaces used, light and display are commonly used on the robots. Within the light and display, various variations are being used. For instance, on the display, graphical based contents or textual based content can be used, and also for the lights, different types of lights and patterns can be used. But currently, there are no consensus on what type of content on the display, nor what type of light nor pattern to be used is clear. Hence, this needs a further investigation. In this study, we use a survey to investigate further on what type of eHMI modality works the best for delivery robots to express their intent. We conducted a survey with 152 participants, and the survey was hosted on Qualtrics. The link for the survey was distributed using university mailing list, social media, and flyers. In the study, we considered three different scenarios: the robot moving forward, the robot coming to a stop from motion, and the robot turning. For each of the scenario, various eHMI designs were created based on display and lights. Within the display, variations were introduced by changing the type of content, either textual messages or graphics. And within the textual messages and graphics, further variations were introduced by adding the perspective of the robot to the message. And also for the lights, two types of lights were used, a single strip LED and a dual light. And also within the lights, further variations were introduced by changing the light pattern by using flash and a sweeping pattern. The following animation shows the three different scenarios: the robot moving forward alongside a pedestrian, the robot coming to a stop from motion in front of a pedestrian, and the robot turning in front of a pedestrian towards the left. In this study, only left turn was used since the results of the left turn can be extrapolated to a right turn also. The animations were also shown to the participants during the study for them to understand the scenarios considered in the study better. The following are the designs created for a forward scenario where the robot moves forward in front of a pedestrian. The top row shows the various display-based designs created. The first two show the display-based design with graphical content. The first one shows an arrow which doesn't have any perspective of the robot. The second one shows an animation with a robot icon. The robot icon adds the perspective of the robot. The last two on the top row shows the display designs with textual content. The first one simply has the message moving, and the second one has the message robot moving. The robot term adds the perspective of the robot to the content. The bottom row shows the various designs with light-based eHMIs. The first two shows the designs with LED strips, and the last two shows the designs with dual lights. The sweeping and flashing pattern are also introduced within each of the light designs. The following designs were shown to the participants during the survey. Similar to the forward scenario, the following are the designs created for stop scenario. The top row contains the designs based on display, and the bottom row contains the designs based on LEDs. Similar to the previous one, the following are the designs created for the turn scenario. The following are the outcomes that were measured during this survey. The participants were asked to rate each of the design under all three scenarios. The participants were asked how clear each of the design interface were in expressing the intent of the robot. The participants were asked a rating on a scale of 1 to 7. The participants were also asked to rank all the 8 eHMI designs for each scenario, from the best in expressing the intent to the worst in expressing the intent of the robot. The participants were also asked whether they feel a combination of light and display makes more sense than using a single design. In case the participants felt a combination makes more sense, they were asked to pick a combination with a one light design and one display design which works the best for them. The participants were also asked for qualitative feedback, asking about their design choices. In addition to those, the participants were asked about their prior experience with delivery robots. It was seen that most of the participants either had experience using a robot or seeing a delivery robot in action. When investigated about their perception about the delivery robot's navigational intent, many indicated that they had uncertainty in expressing their intent. This clearly established the fact that further investigation on the use of eHMI is needed. The following slide shows the results of the clarity rating for the display eHMI design. The y-axis of the plots shows the clarity rating on a scale of 1 to 7. 1 meaning the eHMI design did not explain the robot's intent, and 7 implying that the intent of the robot was very clearly explained using the design. For the forward scenario, text-based content was preferred over graphics. The interaction between the type of content and the perspective information was not significant. Overall, text-based content was highly rated over the graphics. For the stop scenario, an interaction effect was observed, and the main effect analysis showed a statistically significant difference between text and graphics, with text being preferred over graphics again. Interaction effect was seen for the turn scenario also, and there was no significant difference between the use of text and graphics. The following slide shows the clarity rating results for the light-based eHMI. For a forward scenario, an interaction effect was seen, and based on main effect analysis, significant difference was found. Overall, dual lights were preferred. In the stop scenario, no statistical difference was found. The turn scenario had an interaction effect with a statistically significant difference in the rating. Dual lights were highly preferred, similar to the forward scenario. The following slide shows the outcomes and the results of the clarity ranks given by the participants during the survey. The rank given by the participants for each of the designs were normalized to a score between 0 to 1. A rank of 1 was given a score 1, and a rank of 8 was given a score of 0, with the ranks in between getting scores between 0 to 1. The table shows the means of the ranks given by the participants. Based on the means, it can be seen that display-based designs were highly preferred for all the three scenarios. For a forward scenario, text without perspective was highly ranked, and for the stop, text with perspective was highly ranked. Finally, for the turn scenario, display with graphics without the perspective were preferred by the people. When asked about the combinations, many people indicated the combinations were good. The following slide indicates the count of each combination preferred by the participants. Based on the chi-square test, no statistical difference was found in the data. The qualitative feedback of the people were analyzed thematically. Many indicated that though text was clear, they were concerned about the text making sense on a global level due to the language constraints. Many also indicated that auditory feedback adds more value since at times people may not be looking at the robot while walking on the sidewalk. People liked arrows since they were very clear and simple to understand, irrespective of language and age boundaries. Cues based on automobile designs were also preferred by the people since people already are aware of meaning of each of the design. Finally, from this survey, we learned that display is a better eHMI choice in expressing the intent of the robot. One type of display content cannot be used for all scenarios, and hence the robot needs to use different type of content based on the scenario. Though light was not preferred as an effective eHMI independently, many preferred light being used as an auxiliary eHMI in addition to the display. Thank you for listening to the talk. In case of any questions, feel free to reach out to any of the authors and we'll be happy to answer your question. Thank you.